Hey guys, welcome back. I wanted to take up some homework for RL series circuits. This is actually number 16 out of your workbook. It's Unit 2, handout 2. Number 16. A lot of times students have trouble with this one, and so I just wanted to take it up, see what's going on. Have a look at the circuit here, 200 volts. This is XL, right? 60 ohms resistor, 70 ohms. Look at XC, no value. It does say that the total impedance of this circuit is 100 ohms though, and then it's asking for the current, and then C, which is I guess the capacitor in farads, right? Phase angle on whether the thing is leading and lagging. This one's kind of tricky though, guys, so have a look here and we'll see if we can figure it out. I guess it's tricky because, you know, it doesn't give you the three values, so it's harder to draw, you know, a nice phasor diagram for this thing, but let's try. When in doubt, guys, even if you don't have the values, see if you can draw the phasors for them. Now, let's see, we'll draw the phasors that we know. This is a series circuit, so I'm going to compare all my phasors to the current here, and there's the resistor. I can draw it. It's 70 ohms, so let's put it on here. It looks like this, right, guys? R is equal to 70 ohms. And I also have XL. It's 60 ohms. It's going to get drawn here with the current lagging, and maybe I'll draw it in blue here for a sec. Here's XL. Now, this capacitor, you know, even though I don't know its value, I do know it exists. So I'm going to draw it on here. And there's actually, you know, two kind of possibilities on this circuit. That's actually what makes this one tricky. XL could look like this, or XC I should say, okay? XC is equal to I don't know what. And if that were the case, then Z would be sitting right here, right? There would be Z, and it's equal to, looks like 100 ohms. And now that I know Z, you know, given R, I should be able to actually calculate X right here using Pythagorean theorem, right guys? And then if I know X, maybe I can calculate XL. The problem is with this particular question that there is actually two possibilities, all right? Because I could have a situation that looks like this, and I simply don't know right now. So we'll draw them both. This is going to be the same. I'm going to have R here. On the bottom, it's 70 ohms. I'm going to have XL. $60 ohms, okay? But XC, it could look like this. And I don't know what it is, but what I'm saying is it could be, you know, either less than XL or more than XL. I'm not sure which one exactly. But if that were the case, then Z would be right down here, right? And we know that Z is 100 ohms. And either way, X in this case would be here, and I should be able to calculate it either way. So I don't know which one it is, guys, but we're going to calculate X anyway, and X will be the same regardless of which one it is here. Okay, so X, it should be equal to, well, let's do it right down here. It should be the square root of 100 squared minus 70 squared, right guys? And so this is Pythagorean theorem, but I'm solving for the short side, so it's the hypotenuse squared minus the other short side squared. That's just, you know, Pythagorean theorem transposed for A or B, I guess you could say, if C squared is equal to A squared plus B squared. So let's calculate it here. It's 100 squared minus 70 squared equals root equals, and it looks like X is 71.4 ohms. All right, so 71.4 ohms. And if I calculated this one, it'd be exactly the same thing, right? 100 squared minus 70 squared, square root. So this one would also come out to 71.4 ohms. Now, if you look at these two possibilities, there's only actually one that makes sense, because look at this blue line is 60. And supposedly this little bit of it here is 71.4. There's no way I can subtract something from 60 and get 71. I mean, no positive number at least, right? So this one does not make sense. However, this one's possible. I mean, I got 60 up, and then this gray line here, which is XC, is, longer than 60 plus another 71.4. Okay, so what that means is that this is not true, and this is the correct circuit. Now, I can calculate XC here. It's going to be equal to 60 plus 71.4. You can see that gray line is that whole blue line plus this little bit right there. And if I add those together, I get 131.4, I do believe, ohms, okay? Which means we've calculated this right here. It's 131.4 ohms right there. And all that so that we can calculate C, because actually I can calculate it right now, right guys? Because I know the voltage and I know the impedance. So I is going to be E over Z, and that has nothing to do with all this. It's just, something that can be easily calculated. It's going to be 200 over 100, and it's going to be 2 amps, okay? But C, in order to calculate C, you need to know XC. And so now that I've calculated XC, I can calculate C, because XC is equal to 1 over 2 pi FC, right guys? Which means C is equal to 1 over 2 pi F XC. And if I do that, it's 1 over 2 times pi times 60, okay, times 131.4. Let's calculate that for a second here. 2 times pi times 60 times 131.4 equals 1 over x equals, did I do that right? What do you guys think? Yep, looks like I did. It is, well, 2 blah blah blah, right? 0.0000202. Oops, that's supposed to be an O. Let's do that again. 202. All right. And that is, and let's get up here like this, okay? Move it over 6. It's 20.2 microfarads, okay? So that is this guy right here, 20.2 microfarads. That's the hard part on this particular question, okay? And the phase angle, well, I can calculate it right here. We might as well finish this up. It is going to be opposite over adjacent inverse 10, 71.4 divided by 70 equals shift 10 equals 45.57 degrees. All right, now leading or lagging, what do you guys think? This is the drawing right here. How do I figure out leading and lagging? Identify the current phasor counterclockwise. Okay, so this guy is leading. All right, now is there going to be one like this on the test, guys? Am I going to put this exact same question or maybe something similar to this on the test? No. Okay, the test questions are going to be more straightforward. All right, but I like this question because, well, it's a good one, right? Test question is probably going to look more like this, where I give you the values and you have to draw the phasor diagram and figure out the answers. Okay, guys? So thanks for hanging in there with me. I'll see you on the next one.